Today I'm CNC machining a 3-part aluminium mold to cast my own silicone buttons for the next generation pixel pump. I've never done this before and I have no idea if this actually works. But being able to making things in-house has always interested me. And nothing beats the speed and flexibility of having your own tools. I already have custom silicone buttons for the new pixel pump, but I had to wait months for those to arrive. So today I want to explore if we can bring such a workflow in-house. And if this works, I'll be building my own buttons for future projects before sending any file over to a manufacturer. Also, having a CNC mill in the tool belt is a dream come true. And it'll be so awesome for future projects in general. This is probably gonna be a long one, but a quick note before we start. Carvera reached out and asked me if I would be interested in playing around with their Carvera Air CNC mill, and for sure I said yes, as I had this project on my list for quite a time now. I got it for free, but the video isn't sponsored by Carvera in any way. I can and will say whatever I want. My name's Robin, welcome to the shop, let's go. There's two things we need to take care about before using the machine. There's a vacuum and a compressed air connection. Both of these are routed to the tool head for chip clearance and tool cooling. For now I don't have a dust collector, so I'll just use my shop vac to clear the chips. Unfortunately, it is not the right diameter, so we have to take care about that first. While this is printing, we can take a look at the compressed air supply. It uses a regular 8mm air hose, and by coincidence I have one of these from an old project. Fortunately, it already comes with a small flow valve, which is great because then we can turn the air all the way up in the machine and control it externally while it's running. My air compressor though comes with a standard quick release. But luckily Marius had some spare fittings and some spare time and turned us an adapter. And now we can hook things up and fire up the machine. This machine is currently making a PCB and it's really quiet. I mean, it's just a PCB, it's not aluminium, but I didn't expect it to be this quiet. So the PCB as such came out great. The copper was milled away just fine. There's only one problem, it didn't mill all the way through. And this is part of the examples that came with the Carvera, so I didn't do the cam for it. But by reading the instructions again, I saw that I took the wrong PCB. There's a double-sided, which I took, but I should have taken the single-sided PCB. So I ran it again. And it's a lot better, it almost came through the bottom surface. Now I don't want to go into this too deep, but I'll recalibrate the C-probe and run it for a third time. If I would have done the CAD, I'd probably just mill it a bit deeper into the baseboard, so this is not even an issue. Again, the PCB turned out great, it just didn't mill all the way through. Now I don't think it's something with the machine, I just think the cam is a bit too conservative. I would have cut a bit deeper if it would be my design. So it's not a big deal since Carvera included a complete PCB, which I'll just use to proceed. This part looks great. It cut all the way through and also into the baseboard, which is something you actually want to make sure that it's cut all the way. Honestly, I'm really surprised how well this turned out. I was really curious about the aluminium part. Sure enough, it is a nice part. Unfortunately, I don't have any soft jaws yet, but I found this relatively hard rubber with the sticky tape, and I think that's gonna do it for now. I really enjoyed building the example that came with the Carvera Air. It covered a variety of materials and the results are pretty nice. But I think it's now time for a real project. I haven't done any CAD in at least a decade or so, so I spent the last few days researching and playing around with Fusion. I think I now have a basic understanding of how things work, so let's take a look. I quickly designed a small demo piece which covers a few of the basic CNC operations. I'll be cutting off a 10mm thick piece of what I believe is 6061 aluminium bar I got from a local scrap dealer. I won't be machining this test piece from both sides and I'm fine with having the bottom of the stock untouched. Next, we'll start by taking off some material at the top. A facing operation starts slightly above the stock and works its way down until we reach the top surface of the model. I made sure to leave some surrounding stock so I don't run into my hold-down clamps. I chose a vertical step over of 0.15mm with a finishing pass of 0.1mm. Next, we'll be roughing out our pocket with a 2D adaptive clearing tool pass. With our pocket roughed out, I chose a 2D contour for the finishing pass, which should give us a nice and clean sidewall in our pocket. Next, I'm switching to a chamfering tool to take off the sharp edge of the pocket. I made sure to set the tip offset to 1mm, or the tool will basically chamfer right at the tip. A roughing pass of 0.15mm followed by a smoother 0.1mm pass takes the load off the tool, resulting in a smoother surface finish. With most of the machining done, we can carve out our part using another 2D contour. I added tabs to prevent the part from breaking free randomly. In the heights tab, I made sure the milling operation goes beyond the bottom into the baseboard by 0.5 mm. This way we don't run into the same issue with the PCB as before that didn't mill all the way through. With another chamfer done on the outside, it's time for the center bore. I kept it till the end because I thought this operation is the most likely to break a tool. A boring tool path with a 2mm end mill is spiraling into the part to create a 2.5mm hole for a thread. The last operation is yet another chamfer to complete the bore. Alright, so this turned out amazing. The flats are so nice and the chamfer is really smooth. The walls have a near mirror finish, very little chatter. Let me just break it out and we can take a closer look at the bench. The tool paths as such, they look rough, but I can tell you those are really smooth. Same with the chamfer. It's just absolutely amazing. And check out the mirror finish on the side walls. That's incredible. With the part looking and feeling great, I was also curious about the dimensional accuracy of the machine. So this part is supposed to be 30 millimeters wide, and I would say 30.07 is kinda close enough. I was also curious about the spindle runout, and 1/100th of a millimeter is actually a really good value. And lastly, I wanted to check if the spindle is perpendicular to the bed, so I 3D printed a little jig to run a dial indicator across the surface. And while in reality I'm kinda only measuring the varying thickness of the MDF baseboard, I just kinda wanted to rule out any major issues. And 0.5 millimeter across an 18 centimeter circle is kinda okay-ish for the accuracy of this measurement method. Alright, the machine is ready, so let's make our mold. In Fusion, I brought in my existing button design and used a Boolean cut to subtract it from a solid block. This block later becomes our mold. Because my tool length is limited, I split the mold into 3 separate pieces. So let's start with the most complex one, the bottom section. The two parts didn't fit right out of the gate, and I later discovered that I had a wrong parameter in the finishing pass around the alignment pins. So for now I decided to use a reamer to open up the holes just enough for a nice fit. With the vise aligned, I still need to locate the part itself. For that, I used the manual XYZ probe that came with the Carvera. Knowing the exact origin is crucial when you're machining the second side of a mold, especially since we have a delicate finishing pass in those pockets that should ideally line up perfectly from both sides. Alright, so we crashed our first tool. Unfortunately, it crashed right into Stefan's vise, which is not good. I think I know what's going on. I did the manual XYZ probing, which was fine. I calibrated this tool here to do that. But then I decided to switch camera angle and redo the probing, but I didn't redo the calibration. And the problem was, before I already installed the laser probe, which calibrated itself, meaning I lost the initial calibration for the second time. Long story short, it thought the tool was longer than it is and crashed, right? So it had the wrong C offset, I guess. Let's try again. This time we'll double check if we have the correct 0 point. So the tool is now exactly over the X and Y 0 point, right? It's in Z up. So let's just drive away a little bit in both directions and approach Z0. So we are now at 6. Let's go smaller steps. 5, 4, 3, 2, 1, 0. And now we can check from this angle if we have the right offset, and it kind of looks good to me. Let's go. Run. And I will be right here at the stop button. Changing to the probe. Yes! This looks absolutely amazing. We have a silicone button mold finished. I have never thought that we could achieve this level of accuracy or surface finish quality from a machine in this price category. I mean, sure, things take longer, like this is a 3-hour part or so, but it's not about the speed, right? It's about having the capability to do such parts. All right, so we filled our mold and I have no idea if this is going to be good or not. So let's just put it in the oven and see in a couple of hours. Check out our silicone buttons. Honestly, I'm very impressed with the overall quality. I mean, yeah, sure, we have some, where the silicone has leaked, but that's fine. We can cut that away. The features are incredible. Like every fine detail is there. And we only have one small air bubble up here. The rest is perfect. Like even the small radius up here, it's there. I'm impressed. The only thing I don't like is the surface finish. It's very sticky and it attracts every kind of like dirt and all that. In comparison, if I take my sample, those are not sticky at all and don't attract dirt nearly as much as this one here. I don't think it's kind of a material difference. They're pretty similar. I just think they didn't mill the mold. Maybe they did some EDM machining, or they sandblasted it. So it makes me wonder, what happens if we sandblast our mold and just make another pair? Let's try that. So here we are with our sandblasted mold. I mean, it's not sand. I took glass beads, which is kind of the recommended thing for aluminium. And I think they look kind of cool. The tool marks are removed entirely. Let's apply some mold release and try again. Check out the surface finish. I couldn't be happier with the end result, especially after bead blasting. Those buttons came out incredible. Under the microscope, you can clearly see how bead blasting turned visible tool marks into a nice and matte surface finish. Also, it almost seems like there are some glass beads or aluminium fragments embedded into the silicone. I mean, I had a really intense cleaning action going on with all the brake cleaner and compressed air and whatnot, but it seems like there was still some debris left in the mold. So next time I'll definitely be a bit more cautious here. Nevertheless, there's one very important thing that's still missing and most other silicone buttons have, and that is the print. And now I would love to test if we can UV print on those using our UV make. And if that works, we're gonna have custom silicone buttons for all future projects from now on. How cool is that? Now, silicone isn't easy to print on, and that's mostly due to the low surface tension. Your ink would love to just bead up and fall off like a raindrop. To fix that, we need a quick surface treatment. I only have 2 shots, so this better work straight away. Now the printer is currently injecting ink as we haven't used it for a while. But to make sure the printer is all flushed out and ready, I'm gonna print onto this old S&D magazine first. The printer's ready, so we are ready for test number 1. It's a bit misaligned, but the print sticks surprisingly well. It came out a little thinner than in my design though. For the next run, I'll set the white underbase choke to 0, loaded the second specimen and hit print again. And yes, this time it just looks awesome and it feels like a huge success. Now you might wonder, why did we not just 3D print a mold instead of going through all of this? Well, I wouldn't use FDM simply because of the coarse layer lines along the side walls. SLA would be a much better option, and there are many resins that can handle the 140 degrees C in the oven just fine. But I'm just not into the resin mess at all right now. Also, if you need a high accuracy or a better surface finish, you'll probably have to go for machining anyways. All things aside, it just made a ton of fun too. It's refreshing, especially since I'm usually only doing additive manufacturing. Now I'm honestly impressed with this machine. It's far better than I expected a CNC in this category. Also turns out to be a real tool and I'm genuinely happy to have it in the shop. And making the silicone mold raised a dangerous question. What else can we build now? Those tiny desktop injection molding machines suddenly look a lot more tempting. Especially knowing that we can probably machine our own tooling for them. If you're thinking about upgrading your own shop, I can highly recommend giving this machine a look. I'll drop a link in the description. There's also a $100 coupon code you can use at the checkout. It's an affiliate link. It helps me make those projects and I get a small cut without you having to pay more. Alright, that's it for today. I need to clean up this mess here and jump straight into the next project. Thanks for watching. See you next time.